Okay, lots of information given to us in question 6. A student determined the relative molecular mass of an unknown volatile liquid Y in the experiment shown. So what they're doing is they're using a hypodermic syringe to inject a sample of Y into a gas syringe in an oven. And at the temperature of the oven, liquid Y vaporized. We've got the results shown in table 2. Okay. So using table 2 then, we've got to determine the relative molecular mass using the experimental results and the gas constant, which is 8.31 joules per Kelvin per mole. Now, in order to do this then, I'm going to be using 2 equations. I've got the idea that mass is equal to the number of moles times the molecular mass, and that PV is equal to nR times T. Now, you can either do this in 2 steps or you can combine the 2 equations together. I'm going to do the equation in 2 steps. If you prefer to do it all as one equation, there is absolutely nothing wrong with that. So I'm going to start off with PV equals nRT, because what I'm going to try and work out is N. So to rearrange that, I'm going to do N equals PV over RT. Now, just going to bring back my values that I've been given in the question, because actually most of these aren't in the correct units. So the first thing I'm going to do is convert these to the correct units and look at how I would do so. So first of all, I've got an oven temperature of 98.1 degrees Celsius. Now I want that to be in Kelvin, so I'm going to need to add 273 to that number. I've then got an atmospheric pressure in kilopascals, which I would like to be in pascals, so I'm going to have to times that by 1,000. I've then got a volume of 85 centimetres cubed, which I need to be in metres cubed, so I'm going to need to divide that by 1 million, or 1 times 10 to the minus 6. So that will give me then some new units to use. My pressure should be 102,000 pascals. My volume should be 85 times 10 to the minus 6 meters cubed. Notice that I've taken the time to write on my results table and also rewrite my values on my exam question. The reason for that is that the examiner will just be given the section for you to write your answer in. So I want to make sure that I've got all the information I need right here to be able to refer back to, and the examiner can then see the actual numbers I've used in my calculation. Otherwise, if I do make a calculator error and I haven't written these numbers, I would be far more likely to lose the marks there. So to work out N then, I'm going to use these numbers, and I'm just going to do a simple calculation. Well, I say simple. 85 times 10 to the minus 6 over 8.31 times 371.1, and it brings out N at 2.8114 times 10 to the minus 3. Now I'm going to keep that on my calculator. Okay, so the number is a little bit bigger than that, but I've rounded it just for my working out purposes. Because the next thing I'm going to need to do is work out the molecular mass. Now in order to do that, I'm going to need to do a calculation of the mass divided by the number of moles. Now I've got my number of moles, but if I go back to my question, they've told me the mass before the injection and the mass after the injection. So that tells me then, by doing a quick subtraction, which should come out as 0.21, but I did do that in my head, that the mass of liquid Y is 0.21. Now notice again, I'm writing that out on my sheet so the examiner can see exactly what numbers I am using. And also, because I've been able to do that in my head, I can very quickly just divide my final answer on my calculator by 0.21. Helps if I get my numbers the right way around. I do apologise, they should be the other way around. I've written them in the correct way on my calculator, giving me an answer of 74.7. Now, from there then, we've been told that some of the liquid injected did not evaporate. okay, some of the liquid did not evaporate because it dripped into the gas syringe nozzle outside of the oven. We need to explain how this would affect the value of the molecular mass calculated. Now, if some of the liquid did not evaporate because it's been lost, it means the volume is lower. Now, because the volume is lower, that will ultimately have an effect on the molecular mass. It will lead the MR to be larger than expected. Now, the reason for that then is going to be, if we take our equation, we know that N equals PV over RT. Now, we're changing V, so let's assume P and RT to be constant. Now, as a non-mathematically minded person, I don't know if you maths people do this in the same way, I'm going to need to put some numbers in. So I'm going to assume that P is constant. I'm just going to say it's 1, and I'm going to assume that RT is 2. Now, if I have a larger volume of 10, and then I'm going to reduce the volume, and I'm going to do 5 over 2. So my values for N would be 10 over 2 would give me 5, had to think about then. 5 over 2 would give me 2.5. So a smaller volume has led to a smaller value for N. Now my next equation is going to be MR equals M divided by N. So if I again make M constant, I'm going to make M have a value of 5, and I'm going to do my larger volume, which gave me an N of 5. So here the number of moles would be 1. But at my lower volume, the N was smaller, so it's going to be 5 divided by 2.5, and it would give me an MR of 5 divided by 2.5 would be 10, wouldn't it? No, it would be 2, sorry, simple maths. Use a calculator. So it would give me a 2. So the MR would be larger. Thank you.